So we have two elements of interest now, right? We have element A and we have element B. Okay, so given to us, so this is example number 3. Okay, so so we by looking at it, right? So we are given a transformation. So the transformation is they declare that this is x, okay, and this is y, right? So when that's the case, when you do on the isometric view, we know that this is your x, right? This is your y, and this axis is your z. And if we draw our geometric axis relative to the elements, okay, it looks like this, right? It looks like this. So this is our geometric axis relative to our element. Okay, so this is our geometric axis. Okay, then from here we are going to again. I'm just down here. I'm just going to show you how to identify the moments and the torque, okay, and the shear force. I'm not going to teach you yet how to calculate the stresses for the shear, okay. You don't know how to do it yet. That's for the next chapter. But bending moment, you know already, okay. Bending moment, okay. So again, nothing changed. Procedure is exactly the same, okay. We are going to view this in the XY view. So, okay, so I'm now, I like to view this in the XY plane now. So this is my, oops. So this is my X and this is my Z. Okay, so when I view it from that view, what I'll see, okay, I'll see something like this. Oh, hold on. My computer is very slow now. Okay, I think it's because of my, hold on. I need to reduce the brightness. It's heating up and right. So we put in our geometric axis. So there is our geometric axis. Then I'll put in our elements. Okay. So if I were to draw the hidden feature, there are lines over here. Right. This is the web. And we know that over here, if I draw over here, we have our elements A and B. Okay. Elements A and B. So over here, we can see that we have a load coming down. Okay. And this is 90 times 10 to the power 3. And then there's a force, a dot, coming at 20 times 10 to the power 3. Okay. So we only focus on the A ignore the dots and the crosses. For this case, it's pretty straightforward. So from here, we know that PZ, right? We're aware that PZ is equal to 90 times 10 to the power 3 pounds. Okay. Then if we have nothing else to do, sorry. Then we view from a different view. Now the next view is where it's very, very important. Okay, so the next view that we're going to do is we are going to look at the XY plane. Okay, we're going to look at the XY plane. So I'm going to sketch this in the XY plane. So this is our X. Sorry, YZ plane. I do apologize.
Eugene, I don't know if it's
Yes.
just me or your screen is frozen. I don't know if that if that's just from my side.
No, you are right, because if I see, let me close it down. Let me stop sharing and share again. Go on. Go on. It's my bad. Yeah. Thank you for telling me, okay? Yep. Okay. It's okay now, right? When I move, it moves, right?
Yeah.
Okay. Okay. So 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 y'all missed the first figure, right? What I'm talking over here. So what I did is I sketched the XY plane. This is the view that we get, right? And then the forces, you have the 90 times 10 to the power 3. You have 20 times 10 to the power 3. Ignore the dots. Consider the full arrow. And the 90 times 10 to the power 3 will induce an axial force, right? Because it's acting parallel to the geometric axis. Okay. So the next thing we're going to view is on the YZ plane. Now this is where it's the most critical. Okay, the YZ plane, and I'll tell you why. So if I were to draw the YZ plane now, right? Then we have this thing down here. Then we have our element B. And then we have our element A. And then I'm going to put in my geometric axis relative to the element exactly over here. Okay. Now, this is where things get interesting. Okay. So I picked it. So we know that we have a distance away, a force over here. This is 90 times 10 to the power 3 pound. And then we have a force over here. This is 20 times 10 to the power 3 pounds. Okay. So what's so interesting about this? Okay. Yeah, what's so interesting about this? So we know, right? Let's look at the 90. The 90 is parallel to the geometric axis. Okay. So the perpendicular distance is up to the geometric axis. You'll see that, right? Whereas the 20 times 10 to the power 3 is perpendicular to the geometric axis. So from that, when that's the case, you go right down to the what? Element. Can you see that? So this distance we know is 24 inch. Right? So a lot of students were confused, right? About the 90. The 90 is to where, right? So if they were some student, I'll show you how many times I've been teaching this course since I come to McMaster. Okay, I think I can show you that. So if you look at my folder over here, right? And in my folder is 303. So I started teaching in winter, okay, 27, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You are my 13th batch, okay? And everyone makes this same mistake, okay? And because they don't listen to the rules, right? So what is this mistake, okay? So when the force is parallel, okay, when the force over here, right, is parallel to the geometric or your geometric axis, the moment is to the geometric axis. What they did wrong is, oh, I'm interested in element A, this should be the perpendicular distance. I'm interested in element B, this is the perpendicular distance. I mean, element B happened to be right, but element A, this distance is wrong. Can you see that? Okay, that's where the problem is. Okay, so obey the rules. Okay, so from here, and when is it to the element? I'm not saying to the element is wrong. Okay, if the applied force, now you can see over here, if the applied force, bad color to pick, if the applied force, right, if the applied force is perpendicular to the what, to the centroid or the geometric axis, then you go down to the what, you go down to the element. So there are times that we go down to the element, there are times that we go down to the what, geometric axis. Is all dependent on relative to the what, geometric axis. Okay, so parallel, if the applied force is parallel, like the 90, right, it's to the centroid or geometric axis. If it's perpendicular to the geometric axis, like the 20 times 10 to the power 3 pound, you go down right to the element. Are we clear? Okay. So before I go on, we need to find out what is this. So we need to find out what is this W828. Okay. So you go to the books. Okay. You go. So W828. Okay. So you go. If sometimes if I'm doing a homework, I don't give you those values. You just go down to here. W828, W828, and we are going to find the distance D, W828, W828, the D value is 8.06, right? So you can see WD28, W828, 8.06, okay? So you come over here, this distance is 8.06 divided by 2. Okay. So now you calculate your perpendicular distance. Okay. So you can specify now that positive is in this direction, right? So we are going to calculate. So this is rotation in X, right? So moment about X is equal. So we are saying clockwise is positive. So 90 times 10 to the power 3 multiplied by 8.06 divided by 2. Now the 20 is going in a anti-clockwise direction, right? Relative to element A and B. So it's minus, so it's equal to minus 20 times 10 to the power 3 multiplied by a distance of 24. So this will be equal to 90 power 3 times by 8.06 divided by 2 minus by 20 power 3 times by 24. So it's equal to minus 117.3 times 10 to the power 3 pound inch. I'm going to do it again. So 90 power 3 times by 8.06 divided by 2 minus by 20 power 3 times by 24 is equal to 117.3. So the negative means that the correct, if the direction is going to be which way? In the opposite direction. So immediately you write over here, right? This is your moment of X, right? So if we analyze this in terms of bending moment, this is good revision for you. Also stress in the z direction is equal to mx over ixx multiplied by y. And we know that element B, so stress Z of element B is equal to 0, right? Because it's equal to 0 because y is equal to 0. Okay. Whereas at point element A, right, it's going to be what? Is going to be, so this is compression. This is tensile. So it's going to be positive. Are we clear? Okay. And then another force to look at is your shear force in Y. So the shear force in Y is going at 20. So over towards the right is positive. It's 20 times 10 to the power 3 pounds. Okay. Nothing to do with the plan view. If you draw the, if I'm going to sketch the plan view just out of curiosity,